Hello everyone. This is a replacement session for session 1 of the Schulich Ignite program, as our first session was unfortunately lost due to technical issues. I'm also hoping to go into a bit more detail than we had time for in that first session. Unfortunately, again, due to technical issues and some time overruns, we ended up not going into as much detail as we would have liked on some of the topics. So here we hope to kind of expand on the stuff that we were doing there. So, getting right into it, my name is Liam Rubleski. I'm going to be the lecture lead for the summer 2020 Schulich Ignite sessions. I'd like to welcome you all here. I hope to work closely with as many of you as I can and see how you guys progress over the course of our sessions together. Without further ado, we'll get into our presentation. So, as a very, very brief overview of the program, what we plan to do here is a few different interactive sessions where we'll explain the basics of programming in the language Python, specifically in Python processing. We'll go over that in a bit more detail in a bit. But the way that we're trying to teach this is an exercise and project-oriented approach to it. So we don't want it to just be me talking at you for an hour a week for 6 weeks and then you do a thing. That's not really what we're going for. What we're going for is an experience where you guys are working on exercises, you're working on projects, and as you go through those, we give you the knowledge that you need to succeed in doing those. So we really value your creativity. We want you guys to be creative. We want you to make cool things. And that's really what we're trying to do. And so the workshops that we're doing, we're trying to give you enough examples to see how these bits and pieces can fit together in order to make something really, really cool. And we're hoping to see some really cool stuff from you guys this semester as well. So in terms of the actual content we'll be going over, today we'll be talking about variables and mouse movement, kind of to start with, as well as setup and draw, which are, for the moment, we're not really going to talk about what they are. They're effectively just some of the structure of how a processing program has to look. In the next session, we'll talk about operators, and then we'll talk about how we can move things. So this session will mostly be drawing things that are static, or occasionally they'll rely on user input, like the mouse position. But in the next session, we'll talk about things that move on their own, so you can create some really cool animations in games and such. In session 3, we'll be talking about if statements and logical operators. That gets us a lot of program flow. So how do we change how the program behaves when the user does something? Then we'll continue on into arrays and loops. Those are a bit difficult to summarize here, but suffice to say they're very, very useful for doing things a lot of times. And then the last session that we'll do is functions. And those are, again, they're very helpful. You don't technically need them, but they're very, very useful. And in fact, if you tried to write a program without functions nowadays, people would look at you like you were crazy. So let's continue on. As a brief aside, any content that we put out will be available on our website at schulichignite.com. It might be a little bit out of date depending on when you go looking for it, because we try and do these slides I don't want to say as late as possible, but we try to do it so that we have all of the stuff that we might possibly want to address ready. But we do recommend that you visit there, you check there if there's anything you're looking for. We should have all of our examples up there. All of our slide sets will be up there. Pretty much, if there's anything you need to know, that's one of the best spots to go. So we talked about this a bit in the in-person session, but I'm just going to go over it again. In the in-person sessions that we used to do, we used to have a system wherein we would give out small prizes to people who answered questions. Unfortunately, we can't really do that while we're delivering these sessions over Zoom and over the internet in general. So we've come up with an alternative solution. We have a points-based system that we're calling Ignite points. You can earn these by solving in-class questions, submitting weekly challenges, or submitting projects. And then the people who have the most points at the end will win some prizes. The rules are available at the link in the slide set, and if you feel like going to check that out in particular, I do recommend it, but I'm going to summarize here. So you can see the breakdown of how many points are awarded per activity. So in-class questions are about 10 to 20 points. End-of-session exercises are between 25 to 50. Weekly challenges are 50, and projects are up to 250. Sorry, let me just quickly hide my camera. Up to 250. And the prizes at the end are some Amazon gift cards. So it's not a lot, but we do hope you guys participate, and we'd like to have a little bit of incentive for you guys to do that, aside from just bragging rights. But those are pretty good too. That symbol in the top left corner of the slides will indicate questions that can earn Ignite points when answered. So those will be questions that I will ask. You should answer those in the Zoom chat. And end of session exercises will also have that symbol, and those should be submitted as a processing file to the form listed there. One thing you need to make sure of is that your file name doesn't have any spaces in it. That tends to break things. So if you need to break up words, use an underscore or a dash, but don't use spaces. Then we have social media weekly challenges. Those will be posted on Instagram and Facebook at 5 o'clock every Wednesday, and those will be due exactly 1 week later on Wednesday at 5 o'clock, which is about an hour and a half before we start our session. Those will look something like this. They'll look a bit different. This is from the winter session, but this is one of the challenges that we posed to students in the summer session. So this was to have a smaller object that orbits around a bigger object, kind of like planets. So again, we talked about this in the live session. What is software engineering and what are its benefits? And Dr. Moshepour had some fantastic input. Mine, by comparison, will be a bit shoddy, but let me give you my perspective on what is software engineering and what are its benefits. So all engineering is a process of taking information as to what is it that you want, and then processing that into something that resembles a solution. So it's literally just a mechanism for doing problem solving. Software engineering in particular is problem solving by writing software. So it's a method to solve problems, right? Software engineering isn't inherently different from electrical engineering or mechanical engineering, and that's why you'll in fact notice that a lot of the people in this program as mentors are not necessarily software engineers. I myself am an electrical and computer engineer, not a software engineer, but the underlying thought process is always the same. The benefits of software engineering in particular is that it gives you a way to think about problems that is absolutely brilliant. It's the way that you need to break down problems in order to be successful in software engineering is useful everywhere. So that's like, even everything else aside, that's a very, very useful thing to have, is this kind of problem-solving mental pipeline. But that said, there are a lot of more tangible benefits too. So, as an example, I've written a bunch of software specifically to solve problems that I've encountered myself just on my computer. And this is just things that I'm like, this bugs me, I'm going to fix it. So by learning this stuff, you end up with the ability to solve problems that you might not have even considered having a solution. A specific example is I wrote a piece of software to interface with my coffee machine so that it automatically fills with water. A solution that probably would have cost me a few $100s to buy a coffee machine with that functionality, but I was able to write software to do it, and it was very, very easy. That's the sort of thing that you can do once you have an understanding of how these systems work and how all of this stuff fits together. I don't necessarily recommend everybody set up their coffee machine, but for those of you who like your coffee, it is invaluable, let me tell you that. So, like I said, that's very shoddy compared to Moshepour's perspective, but I hope that gives you guys some idea of what software engineering is and why it's cool. It's a mechanism of problem solving using some of the most powerful tools humanity has ever created. Here's where we would have the icebreaker. Unfortunately, because this is a recorded video, we don't have that, so we're just going to skip through it. So what is the difference between humans and computers? Well, we're all familiar with a few of them more intimately now than we ever have been before. I'm talking to one right now, you're looking at one, and we've all spent a lot more time talking to computers these past few months than we have to people. So you might have some intuition about how computers feel different, but computers also behave a lot differently than people. Computers behave instructions exactly and precisely. So if you ask a person to write 2 plus 2 on a whiteboard, they would know that what you actually want is for them to write a 2 and then to move over and write a plus and then move over and write a 2. If you don't tell a computer to move over, then it will just write them all in the same spot. There's a lot more examples of how computers do things that are technically what you're asking them to do, even though it doesn't seem like it. So the main point to keep in mind is that computers will only ever do what you ask them to. Mostly. There's some exceptions to that rule, but pretty much they'll only ever do what you ask them to, and they will do exactly what you ask them to. So if something's not working, you're not asking right. So with all of that intro out of the way, let's get started. So we're going to talk about the language that we're using. It's processing. So processing is the particular version of processing we're using is based off of Python, which is itself a very beginner-friendly programming language. In fact, I learned on Python 2 somewhere around 15 years ago. So it's been a long time, and Python has only gotten better since then. Strictly speaking, what we're using is Python based in Java, so there's a bit of weirdness that goes on with that, which you might find if you ever go Googling Python syntax, or if there's specific errors that you come across that you might not get any information from Python forums or Python kind of websites, because it's technically Python inside Java. But by and large, that doesn't matter. It's effectively Python, and on top of that, we have a bunch of processing structure. So the processing structure lets us do a lot of things very, very easily. Specifically, it lets us draw things. So one of the problems we find that a lot of these kind of intro programming things have is that they don't give you enough avenue to explore on your own, because it's all console stuff and it's all text-based, and that's not really fun to play with. So what we aim for here is to make it more fun to play with by using processing, which lets you draw stuff very easily and very intuitively. But it also gives us the opportunity to go over all of the syntax and all of the kind of information that you would need for the more classical styles of programming as well. So it's kind of the best of both worlds in that sense. So again, as I mentioned, we're using processing Python mode specifically. So we already have a video on how to install that. Link is in the video description, but I'm just going to go over it very quickly here. So you should be able to see my browser window, which has way too many tabs open. Oops. Apologies for that. So we're going to go to processing.org. Then what we're going to do is click on download processing. Then you're going to want to download the specific version that you need. So if you go to the bottom right of your screen and you see the Windows icon and your start menu looks like this, then you're on Windows. If you own an Apple computer, then you're on Mac. And if you are on Linux, then you probably already know what you're doing. The only other thing to pay attention to is Windows 64-bit versus Windows 32-bit. I can almost guarantee everybody is running on 64-bit, so you should download that one first if you're on Windows. If that doesn't work, then you can go download the 32-bit, but pretty much you should be on 64-bit unless you've got something a bit odd in your setup. Then there's the processing Python mode. So I'm actually just going to switch back to this window and start up processing, which has spawned on my other window. Just give me a moment. So this is what the processing window looks like. When you start it up, this will not say Python, it will say Java. So what you'll want to do is come here and click on that, then go to Add Mode in the dropdown. That will pop up this window. What you will want to do there is go to Python mode for processing 3, and you'll want to hit install. Mine is actually out of date, so I'm just going to hit update. But then that will download, and then once that's finished, you should be able to use Python mode for processing. So I'm going to switch back to the presentation. Yeah, and that's pretty much it. Then you'll just want to switch into Python mode when you have processing running again. As I mentioned, we have a video on that. It's linked down below. So go check that out if you're confused. And if you are still having problems, get in touch with us over Discord or Zoom somewhere. There's all sorts of ways to get in touch with us. You can even send us a message through our other channels. So pretty much, if you're having any troubles, just get in touch and we'll help you out. Okay, so the structure of processing. So, one moment, I just need to tidy up my desktop. So, the structure of processing is fairly straightforward. So, we have the standard menu, and that's kind of just the standard Windows stuff. We'll occasionally need to play around with that, but by and large, it's going to be fairly not useful to us. The first thing that's really useful to us is the toolbar. And on the toolbar, there's two buttons. There's the play button and there's the stop button. The play button will run your current sketch. By the way, as an aside, the programs in processing are called sketches specifically because by and large what we're trying to do is draw things. So when we're drawing, we're sketching. It's where the name comes from. There tends to be a lot of words that are used for the same thing over and over in programming. So having a separate word is sometimes a bit difficult. So sketch is one of the better words that they could have come up with instead of just program, which tends to get a bit confusing. Because in context, you end up talking about a lot of things and it's sometimes unclear what you mean by program. I'm also just going to hide my camera. So that's our toolbar. Then we have some tabs. We can use those for separate files. So if we want to break up our code into multiple pieces, then we can put that in different files, and those will be on the different tabs. I don't imagine we'll be doing a ton of that with the programs that we're doing here. By and large, they should be simple enough to all fit into one file. But if any of you get really into it and you want to do something very large, then the separate files can be quite useful. Then below the tabs, we have the text editor, and this is going to be where we're doing the majority of our work, because this is where we can write our program. So you can already see there's a program in there that does something, but it doesn't really matter what it is. That's kind of what it should look like, though. There's, on the left, there's the line numbers for your code. You can scroll, and in the middle, you can see your code. You'll also notice that some of the text is in different colors. That's called syntax highlighting, and it's a thing that processing does to help you keep track of which bits of your code do what. So the things that are in blue are kind of commands, but we'll get into that a bit more later. Then down at the bottom, we have the message area and the console. So the message area is where processing will communicate to you if something goes wrong. So if there's an error in your code, then that message area will turn red and it'll give you some kind of error message. It will probably not be super helpful, but sometimes it's useful. The main reason it's not helpful is because we're working with Python in Java, not because error messages are not useful in general. In fact, they're some of the most useful tools when you're doing programming. Then below the message area, we have the console. And the console is where anything that we ask the program to print will show up. And again, oftentimes, if there's any error, that will print to the console as well. So with the structure kind of laid out there, let's get started on the very basics of programming in processing. So I'm going to switch us over to this window. And I'm going to make my window a bit larger there. So the basic structure of every processing program starts with this. So it starts with def setup. And again, we'll explain what exactly this means later, but for now, just believe that it's kind of the structure of the program. So in setup, you put all of the things you want to run once. So if I switch us back over to my code window, you can see I've written def setup. And if I hit enter, you'll notice that processing automatically indents it for me. That's important. So we can talk about things as being inside setup, and what that means is that they're indented. So specifically, there's exactly 4 spaces at the front of this line. So every line that we want to be inside setup needs to be indented like this. So the first command that we're going to talk about is print. And print is very, very useful because it helps us keep track of where we are in the program. So it's sometimes difficult when you are figuring out what's going on in your program to figure out what's going on if your program is not working correctly and isn't necessarily telling you all the stuff that you want it to be telling you. So we have print. And print just prints to the console, which is the black box at the bottom. So I'm going to switch us back over to this window. And what we're going to do is start with a very basic program. Now this is very traditional, to write a hello world program. So all this program is going to do is when I hit the play button, it's going to pop up a sketch window, which is going to have nothing in it because I haven't asked processing to draw anything yet. But it's also going to print hello world to the console. And you can see right down there, hello world in the console. And this is our little sketch window. So when we start drawing things, this is what our window will look like. We don't need that for now, so I've just closed it. But you can see this is the very basics of how to write a program. And for those of you who have successfully run that, congratulations, you've now run your first program. Another useful thing that we're going to talk about here is comments. So anything after a hash on a line is ignored by processing. So it's ignored as a comment. There's a couple of situations in which this is useful. The main one is to keep track of what your code is doing. So especially when you get larger programs, it can be very difficult to keep track of what does this bit do, what does this bit do. So commenting lets you do that without interfering with your code. Another thing that's very useful, that comments are very useful for, is to kind of turn off bits of your code temporarily. If you don't want to delete it, but you're not sure if you want it to stick around, commenting it out can be very useful. So I'm going to just switch us back over. So we can see we have print hello world. And I'll add a comment here that says that this prints hello world to the console. Then we'll add another line, and we'll say that this is from the world. So maybe it's hello and then your name. So for me, I put in hello Liam. Now if I run this, you can see that it prints both of those, but maybe later on I decide that I don't actually want this line in here. So I can just comment it out, and again, it'll be ignored. Now, it's easy to underestimate how important comments are, especially when we've just got these simple programs. But they're potentially vital in some more complicated programs because they're sometimes the only way for you to figure out what exactly a program is doing. So some of the programs that I've written as examples for previous semesters have been far too complicated to understand without comments. And even with comments, they're sometimes still really complicated to understand why exactly it works the way that it does. So comment your code. It helps you read it, and it helps other people read it. I think the best thing that I was ever told about comments is that they're for other people, including future you. So you should treat future you as a different programmer, because future you is not in the same frame of mind. They're not thinking about the problem in the same way that you are right now. So write your comments to record what does this do and why did you do it that way. All right, Now that I've beaten that point into the ground, let's go back to our presentation. So the next command that we're going to talk about is size. So as the primary purpose of processing is drawing things, we kind of need a canvas to work on. So size tells processing how big we want that canvas to be. So you notice that when I ran that sketch for Hello World earlier, it made a very, very small window with a very, very small drawing area. And generally we'll want something a bit bigger than that. And size is how we do that. And it's described in terms of the number of pixels. And in general, in processing, when you're describing the size of something or the position of something or pretty much anything along those lines, you'll specify X first and then Y. So you'll specify your horizontal coordinate first and then your vertical coordinate. So in this case, we specify size, width, then height. And the ordering is important. So we will switch back to our code window. And let's say that we want size 800, so it'll be 800 pixels wide, 600, so it'll be 600 pixels tall. So we should have a 4:3 ratio window. And when we run this, we see exactly that. You'll notice that this is very boring. It's a gray box with nothing drawn in it. So let's get into drawing some stuff. I've now made a mess of things. There we go. Let's get into drawing some stuff. So, I'm going to hide my camera again. The first command that we have for drawing things is rect, and this draws a rectangle. So, the first parameter, which is the word that we use for the numbers or the values that we give to these commands, is parameter. So the parameters for rect are x, y, w, and h. So x specifies the x coordinate of the top left corner. So that's how many pixels is it in from the left. Then the second parameter is y, and that specifies how many pixels is the top left corner in from the top of our screen. Now, those of you who have done some plotting in math will notice that this is kind of backwards from how you do it in math. Because in math, the y-coordinate describes how far we've moved up, but here we're describing how far we've moved down. There's a bunch of historical reasons for this. Unfortunately, we kind of just have to live with it. And sometimes it ends up being a bit confusing, but by and large, you will get used to it. Then the third parameter is the width of the rectangle, and the fourth parameter is the height of the rectangle. So if I switch us back to this window, also just going to turn my camera back on. Let's draw a rectangle. So I'm going to add a comment that I'm drawing a rectangle. And we're going to type the command rect. Then let's say we want it to be 100 pixels in from the left, 200 pixels in from the top, and then let's say we want it to be 300 pixels wide and 400 pixels tall. So we're going to end up with a rectangle that is positioned somewhere probably about here and extends about like that, something like that. And if we draw this again, then we see exactly that. So you'll notice that processing kind of assumed some default stuff for us. It assumed that we wanted a border, that we wanted that border drawn in black, and that we wanted the rectangle to be filled with white. We can change all of that, but those are the defaults that processing assumes, and it's useful to keep that in mind. But we've now drawn something, and that's quite exciting. So everybody who's gotten this far, congratulations on drawing something. Generally, you don't get to draw things in programs until you get much further in, so this is one of the really nice things about processing, is it lets us get some visual results very, very quickly. Okay, I'm going to switch us back to the presentation. There we go. Now we're going to talk about another shape, and I'm just going to hide my camera again here. So the next shape that we're going to talk about is the ellipse. So ellipses are kind of stretched circles in general, so circle-like shapes. We specify the coordinates a little bit differently, but you should notice that it looks pretty much the same as rect, and pretty much everything is going to look the same because by and large they're all trying to do similar things. However, for ellipse, instead of specifying the top left corner, we specify the center. So we want the center to be how many pixels in from the left, how many pixels down from the top, and how wide do we want the ellipse to be, and how tall do we want the ellipse to be. And those four numbers describe our ellipse. So I'm going to once again switch us back over. Fantastic. And let's draw an ellipse. Let's draw our ellipse in the middle of the screen. So the middle of our X position is 400 pixels. The middle of our Y position is 300 pixels, and that's coming from 800, 600, both of those divided by 2. And you know what? Let's specifically draw a circle. And so a circle is an ellipse that has the same width and height. So if we specify that width and height are both 100, that'll give us a circle. And if we draw this, then we see a rectangle, and on top of it we have a circle. Now that's also important to note, is that because we put the ellipse after rect in setup, processing draws the rectangle first, and then it draws the ellipse. So when it draws stuff that comes later, it draws that on top. That's important to keep in mind. So if something's not visible, it might just be because it's in the wrong order. So if we actually go into here, and if I just cut and paste the line to draw an ellipse above the line to draw a rectangle, you'll see that the ellipse is behind the rectangle. Again, I don't want to beat that into the ground too much, but it is important to note. We'll just move that back, and we'll comment that we are an ellipse. And let's add a comment that will say on top of rectangle, just so we don't forget. And you can see that you can actually put comments in the middle of lines as well. So that's another thing that is just kind of a good thing to keep in mind. There's a few other shapes that we could go over, but pretty much these ones all work more or less the same way. We have point, line, and triangle, and you'll need to specify 1, 2, or 3 points for those respectively. If you have any questions about those shapes, then please ask your mentor on Discord or through Zoom, wherever. Just make sure that you understand how things work. There's also a fantastic reference for the commands that processing gives you, and that's at pi.processing.org/reference. So if you're ever confused about the ordering of parameters, or if you want to know all of the stuff that's available, you should go to pi.processing.org/reference, link in the video description. Okay. So, as I mentioned before, processing gives us a default color when we start up the programming, or when we start up the sketch. And that default color is white. So if we want to draw something in another color, we need to tell processing that we want a different color. And one thing that's important to note is that effectively what we're doing is we're changing the color of our paintbrush. So anything we've already drawn won't change color. It's only stuff that comes after that will change color. So if we go back to our code window, let's say we want this ellipse to be blue. So we'll do fill, and I'm going to put in some numbers, and I'll explain these in just a second. 00255, and I'm going to comment that that is blue. And if I run this, you can see that we draw a rectangle, and that's in white still, and then on top of that, we draw our ellipse, and that's now in blue. So the way that we specify the color on computers in general is using 3 numbers, and those correspond to the amount of red, green, and blue. So black is no red, no green, no blue. White is all red, all green, all blue, whatever no and all mean. So in this particular case, what that means is that we want to be, when processing tells your computer to draw something, it tells it to turn on some lights in your display. Ish. Those of you who know about screens will know that I'm kind of fudging it, but this is a useful way to think about it. So if you look really closely at, say, your phone screen, you'll find that there's a lot of little tiny lights, and those are just red, green, and blue lights. So when your computer draws a color, it's actually not drawing that color, it's just kind of making a guess at that color using red, green, and blue. Kind of like the primary colors that you might have used for paints in elementary school. But for light, the primary colors are red, green, and blue, just because that tends to be how the human eye works. So if we had a different system, then we would need different colors. But thankfully, we all have the same system, more or less. So we all can use the same colors, and we can all end up seeing about the same thing. So that's the long and short of color. If you have any questions, because that can be a bit confusing, again, please do ask us. I'll also link the Wikipedia page on RGB color space, and that should give you a decent explanation on why it is the way it is. It might be a bit technical, but for those of you who are interested, it will be linked. So if we were doing this live, we would have now about 10 minutes for you to go and draw something yourself. Unfortunately, in our previous live session, we were short on time, so we had to cut this a bit shorter than we would have liked. But if you would like to work on that now, pause the video, go through it, and then come back once you've figured out something to draw. I'm just going to hide my camera and give you a moment. Okay, now that you've finished your drawing, let's talk about variables. Now this is one of the bits that I had to skip over most in our live session, and I feel really bad about that because variables are potentially very confusing, but they're also kind of the most important thing about programs. So in general, variables are containers. So it's like a box, and the box has a label and it has contents. And in particular, we call the label of the box its name, and we call its contents its value. So there's also technically a type, but that doesn't really matter for Python, so we're going to ignore it, except for a few kind of edge cases that we'll mention when they come up. So in general, in Python, when you want to use a variable, you just ask for it. So you just, like the code that we have on screen, we just say age equals 23. Processing will look at that, and it will see that you are trying to access a box with the label name, with the label age. If that doesn't exist, it will create that box and give it the name age. And then inside that box, it will put the value 23. Now what's really useful about variables is we can change the value that's in them, which is why they're called variables, because the value in them can vary. But the other thing is we can pull the value out of them and use that in multiple places. So again, technically they have types. I'll touch on them here, and then we'll go into some examples of how to use variables. So one of the most basic types for variables is integer. That's any whole number, positive or negative. So something like age would probably be encapsulated with an integer, and that's demonstrated there on screen. Age equals 19. That describes the variable age with the integer value 19. So as an example of something that's not an integer, we have floats. So those are numbers that are not whole numbers. So something like 3000.29 is not an integer because it has a decimal point. You might also see these described as floating point. That just talks about the fact that they have this decimal point that it's active instead of being kind of just implied like it is in integers. So an integer is always 0.00000 forever. Floats might be, but they don't have to be. And floats are, again, either positive or negative. They're both the same variable. Then the last one we're going to talk about is strings. And now strings are very interesting because they are kind of how we deal with text and with talking and printing things. So we actually already used a string when we wrote our Hello World program, because you note that when we typed that, we had print, and then in our parentheses, we had quotes around Hello World. So that created a string for processing to use. So in general, Python processing, we can describe a string using either double quotes or single quotes. Here, we'll just be using double quotes for consistency's sake. So I've switched us back over to our coding window. So some examples of why we might want to use variables are for if we have something that shows up in multiple places. So let's say that maybe we don't know what it is we want to print. Maybe we think that we want to print hello world. In fact, maybe we think we want to print it a bunch of times. We want to print hello world 5 times. We're very excited to say hello. But then later on, we decide, maybe I don't want to say hello world. Maybe I want to say hi world. In that case, I would have to come in and change each and every one of these lines individually. And in general, we might not even know where those lines are. We might be using that kind of value later. So you can see, in fact, it's in our comment, and we haven't changed it there. Now, we can't change it in comments in general, but we might have that code later on somewhere, and we might want to change it at that point, but we've forgotten about it. It's a bit difficult to explain kind of the circumstances in which this could come up, but a better example, I'll do a better example in just a moment. But what we can do is make a variable, and we'll call this variable greeting. So by typing the word greeting with no parentheses or anything, I've created the variable greeting. So I've created a box whose name is greeting. And I'm going to set it to the string hi world. Okay? Now if I want to access the value of this variable, I just type its name. And that acts as though I typed whatever was in that variable. So in this case, it would act like I typed hi world, which we already know what that should do. And then, whoops, wrong keys. So then I can come in here and say print greeting. Print greeting. Print greeting. And finally, print greeting. So now if we run this, it will say hi world 5 times, as we can see down in the console. But if we then later on decide that we want it to say something else, so we want it to say hi Liam, we just need to change it in the one spot, and it acts like it's changed everywhere. So that's really important. Another thing we can do with it is we can say, we'll start with hello world, and we'll print our greeting maybe 3 times. And then we can change the value of our greeting. So we can change our greeting to now say hello Liam, and then print it another 2 times. So what this will do is it'll create the box with the name greeting and give it the value hello world. Then it'll use that value a couple times, and then down here we're asking processing to change the value. And so we say greeting is now equal to hello Liam. And so we can see that what happens is it prints hello world 3 times and then hello Liam twice. This is, again, kind of important to note, so I hope I'm not boring you by going over it too much, but it is very important stuff to learn. A kind of better example of where we might want to use a variable instead of typing the numbers directly is down with our circle. So let's say that we decide that we want our circle to be twice as big. So we come in here and we change that value to 200. But maybe we forget to change this one. I don't know, it's tired, it's 11 at night. We just missed that we need to change that. But now we get the totally wrong behavior. We get an ellipse, an oval, instead of our circle. How can we avoid this? Well, one way we can avoid this is by making a variable whose name is, let's actually call this variable diameter. So it's going to describe the diameter of our circle. So if we set this diameter to 200, then we can ask processing to draw a circle at x position 400 y position 300, and its width and height are both whatever is currently in diameter. Right? So if I draw that, it uses 200. And if I want to change it, I only need to change it right there. 200 to 100. And it gets smaller again. Okay? So variables are very useful for that sort of thing. They're very useful because they can change, and we'll get into that a lot more in the next session when we talk about moving things around. We really need variables for that because we need stuff to vary over time. One more thing I want to make a note of before we go into operators is that there are some special variables. There are some special words, actually. So if I try to make a variable called size, you note that that gets highlighted in blue. And that means that processing recognizes that that's an important word. So in particular, it would probably work here to use the variable name size, but I wouldn't count on it in general. So you can't reuse names that are already used by processing. They're called reserved words. And a better example would be something like if, which shows up in green. You absolutely can't use that as a variable name. So if it shows up in green, you definitely can't use it. If it shows up in blue, maybe. But yeah, that's just a thing that we want to note. And while we're here, let's add a quick comment to say that this is the diameter of the circle. Okay, let's go back to our presentation. So the next thing we're going to talk about is operators. Now, operators are kind of the math. Operators in general, the arithmetic operators here are pretty obvious. Like, they all make sense, and they all behave pretty much the way that you should expect. The only thing that might be unfamiliar to you is modulus, right at the bottom. And modulus is another operator. In the same fashion as addition and subtraction are operators, modulus is an operator. Specifically, it behaves a bit like the remainder. So you might remember from elementary school when you learned about division, you would do something like 12 divided by 3 is 4 with remainder 0. But 13 divided by 3 is 4 with remainder 1. So modulus is that remainder. So if we take 5 modulo 2, that will give us 1, because 5 divided by 2 is 2 with remainder 1. You probably won't use it, because it tends to be used mostly for mathematical stuff, pretty intense mathematical stuff, but on the off chance you do use it, that's what it means. And so it's generally useful when you want to have a value that loops around. If you have any questions about it, if you're curious about how modulus works, please do ask your mentors, because I'm sure they would be happy to help you understand that. Yep, that pretty much explains operators. So what we're going to try and do now is make a ball that moves, and we're actually going to need the second bit of structure for processing. So I'm going to switch us back over to code. So previously, the structure that we've been working with is setup, just def setup. And everything we've wanted to do has been inside def setup. Now, in order to draw something that changes over time, we need to have some more structure. And the structure for this looks like def draw. And one thing that I do also want to note, and should have noted earlier, is that it's very important that you write it pretty much exactly like this. So you need def, and then a space, and then the word setup. There's no hyphens, there's no underscores, no spaces inside the word setup. Then you need to have an open parenthesis and a closed parenthesis, and then a colon. So this is the whole structure. That's very important. We'll talk later about why it's important that the structure be this way, but for the moment, you just kind of need to accept it. And I always hate telling people that they need to just accept what I'm saying without explaining it, but for the moment, it's just a little bit more complicated than we want to get into. So the thing to note is that everything inside setup runs once. So as we go through our program, it says greeting is hello world, then it prints greeting 3 times, then we change the value of greeting, and we print greeting another couple times. And we set up our size, and then we draw our rectangle, and we draw our ellipse. Okay? But all that happens just once, and then it doesn't do anything with it after that. If we want something to be drawn more than once, we need to put it inside draw. Now draw draws over and over again, and so it draws every frame of the animation. So if we want to make something that is drawn every frame, it needs to go in draw. And again, I'm kind of pushing that point quite hard, but it is important to keep track of how often a given piece of code is running. So draw also runs just over and over from the top to the bottom and back. So if we put, if we put a print inside of draw, let's say we want to print that we are in draw. Now if we run this, you'll see that my console is absolutely full of in draw, and it's printing more and more as it continues running, right? Because it's just running that line of code over and over again. But this is very useful for us because it means that we can have things that are drawn over and over again. And as long as we draw it in a different position, then we get stuff that looks like it moves. So if I switch us back to our presentation, we're going to talk about a couple of variables that are built into processing. So those variables are mouse X and mouse Y. So those are boxes that already exist, and they're already named. So they're named mouse X and mouse Y, and that has lowercase m but a capital X and a capital Y. So these variables hold the current position of the mouse cursor. So mouse X holds the current position of the cursor in the horizontal direction, and mouse Y holds the current position of the cursor in the vertical direction. So if we ask processing to draw at mouse X and mouse Y, then we will get something that follows our mouse around. So let's draw, I don't know, let's draw another, let's draw an ellipse with a bit different sizes. So we're going to draw it with the X position, mouse X, so that means that the center of our ellipse should be at our mouse, and with mouse Y, so that means that the center of our ellipse vertically should also be at our mouse's current position. Then let's give it a width of 200 and a height of 150. So that should draw an oval at our current mouse position. And when the sketch starts up, it starts up with mouse X and mouse Y set to 0. But you can see, as I come in here and I move my mouse around, this follows. And again, because we're asking it to draw these after, it draws on top of our existing rectangle and our existing circle. Right? So if we wanted to draw our rectangle and our circle on top of our ellipses, then we would need to draw those in draw too. So as an example, let's say we don't want to draw our rectangle on top of our circles, but we do want to draw we don't want to draw a rectangle on top of our ellipses, but we do want to draw a circle on top of our ellipses. So what we'll do here is 400, 300. For reasons that I'll get into later, specifically I'll talk about this in the next session, we're also going to need to copy this line that describes diameter. So we're going to say 400, 300, diameter, diameter. Okay, and so because we put this after the ellipse that follows our mouse, it'll draw on top. So if we run this again, we move it around, you can see that no matter where I move the ellipse, the circle is always on top. But it's not super obvious, so maybe we also want to change the color of the circle. So let's try that. So let's say maybe we want to draw it in red. So we want all red, but no green and no blue. So what we're going to type is fill 255, 0, 0. Okay, And I don't think I mentioned it earlier, the maximum value for colors is 255. And that comes from a lot of historical computer reasons that are not super important right now. But anything larger than 255 will probably just be treated as 255. So it goes from 0 to 255. And those are kind of the minimum and maximum. So for all red, we want 255, which is 100% red, 0 green, and 0 blue. Let's just make a comment. So if we don't think about it very carefully, what we would expect this to do is to draw our rectangle, then change our fill color to blue, and then draw our ellipse. And then in here, we draw our ellipse at our mouse position, then we change the color, and we draw our circle. So if you're not paying close attention, you would expect that your ellipses would be drawn in blue, but your circle will be drawn in red. However, we see that both our ellipses and our circle are drawn in red. Now the reason for this is because draw runs over and over again. So we can see that what we have is that it changes the color to blue after drawing our rectangle. And then inside draw, we draw our first ellipse, and that will be blue. But then we change our color to red, and we never change it back. So everything after that is drawn in red. And that includes after we go to the end of draw and come back to the top. So if we want to draw our ellipses in blue, then we actually also need fill 0, 0, 255. And now this will behave as expected. It draws our blue ellipses and our red circle. But that's an important thing to keep in mind, and that's the sort of thing where that's why I emphasize that draw runs over and over again. It's because that's the sort of thing that's sometimes easy to miss if you're not paying attention. Okay, we're coming to the end of our presentation, but there's kind of one more thing we really want to talk about before we get into the exercises for you guys, and that is background. So up to now, we've been drawing our background just using the default, right? Just the default gray. But it looks kind of boring, and most of the time we will want our background to look like something specific. So what we do is, in our draw function, I generally put it at the top just because that's how my brain thinks about things, is I want to draw my background first, and then I want to draw on top of it. One moment. Apologies, I needed to deal with my dog. Yes, so I personally always put background at the beginning, and generally that tends to work better, but you can also put it in other positions as long as you are mindful of when it's being done, because what background does is it fills the entire screen, and it will cover everything that you've drawn previously up to the end of the last draw. So for this, let's say I want a black background. Black is 0 of each color. So we say background 0, 0, 0. And that draws our background in black. And then on top of that, we draw our blue ellipse. And on top of that, we draw a red circle. So keeping the order in mind is important, because if we put background after ellipse, then we wouldn't actually see the ellipse, because it would draw the ellipse, and then it would cover it with the background. Let's actually have a look at that, just to make sure everybody's on the same page. I'm just going to cut and paste the line background 0, 0, 0 below our blue ellipse. So you can see that even though we really haven't changed any of our code, we can see that it's still running this bit because it's still printing in draw. We don't see our blue ellipse because it draws our blue ellipse and then covers it with the background and then draws on top of that the red circle. So generally, if you want to have a background, it should be pretty much the first line in draw. One last thing that's kind of interesting to do is to only draw your background in setup, because then it will only run once, and we get the same kind of pattern that we saw earlier with the ellipse, where as we draw, it drags it leaves an after image effectively. And sometimes you want that because it looks cool. Most of the time you don't, because most of the time you're trying to draw something, and having previous frames of the image makes it look worse. Which is also why we use background, is to clear out all of the stuff from the previous frame so that we're operating on effectively a blank slate. But if we do want that, then what we can do is, instead of having background down here, and in fact, let's put that back in. Background 000, that's now in black. So instead of removing it, we're actually just going to comment it out. And this is the sort of thing I was talking about, where it's like, I'm not sure what I want, so I'm just going to comment out the line until I am sure. Then in here, we're going to draw background 000 with comment black. And if we run this, we see a rectangle, which was previously being covered up by the background every time we drew it, so we never even saw it. And we get the same effect where as we move the blue ellipse around, it kind of paints. So this is kind of the easiest way to do that. There are other ways to do it, but this is generally the easiest way to have this kind of visual where you have a trail being left by an object that moves around, is to just not draw a background and keep all of the old images around. Okay. So that's all of our basics. So we have some end of session exercises. So we recommend that you try these. You're not obligated to, but we do strongly recommend it. We would typically budget about 15 minutes for this. So spend 15 minutes working on this, and then after that we have some interesting post-session exercises. So some of the recommended end of session exercises are to go back and finish your drawing from earlier. You can use mouse X and mouse Y to have a ball follow your mouse around on the screen, like what I did with the ellipse. You can draw a rectangle whose top left corner is at 100, 200, and make the bottom right corner follow the mouse. That's a fun one. I do recommend everybody try that, because it gives you a good understanding of how the coordinates work. Then we have some exercises that are worth Ignite points. So we have a rectangle that changes color and shape as you move your mouse around. And we have a ball, or a circle, that changes color as you move your mouse around. So both of those should be good fun for you guys to work on. And then finally, we have some more complicated exercises. So over on the left, we have something where the color change of the ball isn't tied to its location, but it changes over time. So that one's really interesting to work on. I would be interested to see if any of you had some particularly ingenious solutions. And over on the right, we have the ball moving around and a few mirror copies of it that move around interestingly. So those are each worth 50 Ignite points. Partial solutions get partial points. But yeah, that's the end of this exercise. Thank you all for watching this. I hope this gave you a better understanding than our live session, which, again, we had some issues with it, and we have hopefully resolved those for this week's session, which will be happening at time of recording. That will be happening tomorrow at 6:30. So thank you all very much for watching, and I hope to see you soon.